If you were to zoom in on the monitor you are using to watch this video, you would see thousands of small red, green, and blue dots. 3 of these grouped together make up one picture element, or pixel for short. When you split up each pixel, you will see a backlight, 3 color filters, and polarizers. As light leaves the backlight, it travels along different planes, including the horizontal and vertical planes. The first polarizer only allows light traveling along the horizontal plane to pass through it, and onto the color filters. With another polarizer that only allows light to pass along the vertical axis, all the horizontal light waves are blocked, so no light reaches the color filters. This is where the liquid crystals come into play. If you were to look closely at one of these liquid crystals, you would see a transparent electrode on the front and the back, as well as etched glass on the front and the back. Liquid crystals typically orient themselves in random directions until the horizontally etched glass in the rear and the vertically etched glass in the front force them to twist into a predictable pattern. As light passes through the compressed liquid crystal, it naturally follows the path of the molecules, so that any light traveling along the horizontal plane exits along the vertical plane. By reintroducing the electrodes and passing electricity through them, we can get the molecules to align themselves in the direction of the electric flow, causing light to no longer twist when passing through the liquid crystal. When we place these crystals back into the pixel, we can see that the light from the backlight will pass through the horizontal filter, get twisted into a vertical position by the liquid crystals, and then flow through the vertical polarizer to the color filters. However, if we turn on the electrodes, then the light is no longer twisted by the liquid crystals and stops at the vertical polarizer. By adjusting the amount of electricity that flows through each set of electrodes, we can control how much light reaches each color filter, and therefore what color is seen on the display. We generally talk about colors on a display in terms of how bright the red, green, and blue are in each pixel, from 0 to 255. If all 3 numbers are 0, the color on the display appears black, and if all are 255, then the display appears white. As you increase the amount of red, green, and blue in each pixel, you will see different colors appear on the screen. The monitor adjusts the amount of electricity flowing through each liquid crystal one by one, row by row, around 60 times per second. This has been a short look at how LCD monitors work.